so we're going to calculate weighted average. Now they've given you a formula like this, and this stands for the average or the mean, okay? And X bar usually stands for the mean of a sample size, and sometimes they give you mu, and that deals with population, but right now we're talking about a sample size. This here means the sum of, so it means adding up all of the values, and in order to find the mean, we add up all the values of our amount times the weighting divided by all of the weightings. That's what our WI is. So what does that mean as a formula? We take our amount times the first weighting plus our amount times the second weighting all the way to the last one, and we divide it by adding all of the weightings together to find this out. So in this question they said that there was a interview, and these three people were interviewed, and they weighted the first two things, experience 1 and 2, and education, twice as great as the second. Okay, so what you did is you went about finding out what would that be out of 100, but really we just need to get comparisons of numbers. Let's say the interview is considered a weighting of a 1, right? If education and experience are 2 times that, what will their weightings be?
4 double, so 40.
Well, double of just the value 1, so it means it's going to be a weighting of 2 and 2. That's right. And you could use any values. Like you said, you could have used 2, 4, and 4. I could use 5, 10, and 10. It doesn't matter as long as it's double of that. And I'm going to show you how you're going to end up with the exact same idea when we go through this. They said all of scoring was technically out of 5, each category, right? So you were exactly right to find out what the percentages were, right? If this is out of 5, this is going to give us an 80 percentile, another 80, another 80, okay? This will give us 100, 80, and 60, and this guy gives us 100, 60, and 80. Now, if you add up all those percentages together, you're looking at even scores throughout the board, right? Without any weighting. This is what, 240, 240, and 240? Yeah, I think that's right, right? If you were to just kind of add those up. So it looks like they got the same scores, but the weightings are going to come into play. Well, let's talk about this here, okay? This X bar, or X1, those are going to be our percentages, like you said. So we're going to turn them into decimals, and our weightings are these values here, okay? So, our first weighting is a 2, our second weighting is a 2, and our last weighting is going to be a value of 1, okay? So in other words, when I go to find the mean, X bar is equal to whatever my first value of X is for Nadia, and we'll find them for all. So this is just for Nadia, her average score. We got to figure out what X1 is, but we know the weighting of 1 is a 2. Okay, this is our W1. Plus X2 is unknown to us, but it's going to be multiplied by our weighting. Our second weighting is also a value of 2. And finally, the last one is X3. Well, our weighting is only a 1 for that one. That's our W3. And then all of this is divided by the 3 weightings, which are 2 plus 2 plus 1. Okay? So with that being said, this is the formula we're going to use for everybody. What we're going to be doing is inputting our X1, X2, and X3, which are going to be these percentages that each of the people got. Okay? So they're going to give us percentages like you said before. We're going to have X bar. And for the first person, they got 80%. Right? 80%. And as a decimal, that'd be 0.8, right? Times 2. Plus 0.8 again. And the last one, I think, was 0.8. So just to speed this up here. Times 2 plus 0.8 times 1. And all of this is going to be over 2 plus 1 is a value of 5, right? And that makes sense. The total weighting, we had a 2, and a 1. So if you got a perfect score, you would have got a weighting of 5, right? So this is going to be out of 5. So we use our decimals here to figure this out. This is going to be 1.6 plus 1.6 plus 0.8 divided by 5, which is going to give us I think it's going to give us 4 out of 5, right? 4 out of 5. So they ended up within 80%. Makes sense, right? Everything they got was 80. So no matter what the weightings were, they still ended up with an 80. Okay, so that makes sense for Nadia. Let's look at Enzo's scores. Enzo's scores, we'll do Enzo in red here. Enzo, X bar, is equal to, his first score was 100, right? So as a decimal, that's written as the value of 1.00, you would say. The weighting was a 2. His second score was an 80, so 0.8 times 2. And his last score was a 60, 0.6 times 1. All of this is going to be out of what again? That's right, it's all going to be out of 5. Okay, so as an actual score here, this guy got 2 plus 1.6 plus 0.6 divided by 5. Okay, that gives us 3.6. 4.2, that's it. 4.2 out of 5, which is actually, as a percentage, times that by 20, 84. So Enzo's scoring all of this was actually an 84 with that weighted average. Okay? And then finally, our last person, which was Stefan. Okay. He had 100 as his first score, so 1.0 times a weighting of 2. His second score was actually a 60 times 2. And his last score was the 80 times 1. All of it again divided by 5. These values will be 2 plus 1.2 plus 0.8 divided by 5. They're going to actually end up at a 4 out of 5. So with their weighted average, they also got an 80. Okay? So that's where our little mistake was there on the last guy. So it turns out that with the weightings, it's a little hard to see here when it's that far out, but Stefan and Nadia actually ended up with the scores that are pretty much the same. Okay? Because one of their heavy weightings, they got 100%, and another one they only got 60, which kind of averaged out to an 80. Okay? But Enzo ended up with the highest score, so Enzo was the person with the best score in these weighted averages. Okay, so it's always important we just kind of figure out what our percentages are and what our weightings are. And you're right, you can put any weighting you want to one of these questions, as long as the comparison is correct.